All right, as you're starting to write that down, I'll talk to you real quick. Earlier today, I sent out an email that has an additional 12 questions in it as a PDF. They are just for practice. They're just, if you don't want to look at them all, you don't have to, okay? But I would think that it would be a benefit to you in preparation tomorrow to look at them. They have the answers in them, okay? And at the bottom of that email, I also added a URL link to a YouTube video of me doing a handful of those questions, okay? And I tried to, I didn't want to do all 12 of them because I wanted you to have the opportunity to do some of them on your own. But I tried to choose ones that were representative of other ones, okay? So I kind of bounced around in that worksheet doing, I think, about 5 of those questions. So that's maybe a place to reference when looking to prepare for your test tomorrow. The optional review is available. There's 100 questions, and there's a lot of examples in there that you can practice. Okay, and I'm not saying you have to do all 100, but if you're a person that knows, hey, I struggle with multi-step equations, go find those in there, and you can work on them and work on them and work on them until you can feel confident in being able to do them successfully. In addition, if you do have the time, and hopefully you've been working on that stuff already, we did a little bit of math last period and said, okay, if we get a 50% on tomorrow's test, okay, which hopefully we agree that's not really good, but then I did all the optional review, okay, that would actually bolster that 50% into a 64%, okay, which would be a lot better than 50, right? Still, I don't think 64 is a great thing, but rather have 64 go in than a 50, okay? So that opportunity is something that can kind of pad your scores a little bit, okay? So please do that. Yeah. You hear me? There's a seat in the hallway. First thing we have to do here, I have to distribute, okay? So when I distribute, I'm going to go from that 6 and that 1, right? So I get 6, and then plus 6 in, right? Thank you. So 6 plus 6 in, all right? Now here, when I distribute right here, and this is something I've seen a lot of people do, I need to make sure that I distribute the negative, right? A lot of people aren't doing it, and the first term will be right, because they write down this minus sign right there, and they do 6 times in and get 6 in. Well, that's what I get when I take negative 6 times in, right? But then they forget that they're distributing a negative, and they write 36, but they write plus 36. And that's wrong, because what's a negative times a positive? Negative 36, okay? What happens to that person that is making that a positive 36, and this is frustrating, this is very frustrating, is that after they make that error, obviously they've created an error that takes them off the course for getting the problem right. But after they make that error, they don't make any more mistakes with their work. So the idea is that, if we do, I don't know how many steps or how many actual procedural things, but let's say we do like 30 things in this equation. They did one of those 30 things wrong, and then they missed all the points because of it. Does that make sense? Okay? So you have to be very, very, very attentive to detail. Okay? So now we're going to look at this, and we're going to start looking at like terms. So what I like to do is I like to go through and just highlight my constants. And I highlight the constants and their signs. And then I want to go through and with a different color, I kind of highlight my variables on that side. And then I'll go to the other side and try to use maybe different colors and highlight just my variable terms. But I highlight the signs that are with those things. Because now if I look at the left-hand side and I just focus on the green stuff, doesn't it say 6 minus 36? Does that make sense to everybody? Okay. Now, I know you're maybe not carrying around crayons and colored pencils and that kind of stuff or highlighters, but visually in your mind, if you can neglect everything else and look at the 6 minus 36, you can then change that to negative 30. Okay? And then I look at the pink stuff and I see positive 6n minus 6n. Well, what's 6n minus 6n? Just 0, right? So that left-hand side all combines down to just negative 30. The right-hand side, what do I get? What's 5n plus 1n? 6n. And that's usually the place that I'm seeing people make mistakes, is combining like terms, because we're neglecting those signs out front. But if we highlight it somehow, whether you physically do it on your paper, some people like to, when I do things on paper, a lot of times I'll draw like a box around my variable terms and circles around my constants. So I think, okay, instead of highlighting now, add the things that are in circles, add the things that are in boxes, that kind of thing, okay? So somehow develop a strategy that's going to allow me to concentrate on just the like terms. So at this stage, what do? Divide both sides by 6. So that's where we get our negative 5 is equal then to 1n. And there's our solution. Is that all right? Let's do example 2 here. With this example, just be careful. Right here, I've got a negative out front, right? That's a negative what? Negative 1. So you might want to write that in there, and that might help you distribute. Be careful in this one. You've got a lot of situations where you're distributing negatives. All right, so as you guys are working through, obviously I don't want to go all the way because I don't think I give you enough time yet. But we should have, after we distribute, we should have 4 plus 2x equals negative 4x plus 16 plus 4x. When you guys combine like terms, what's negative 4x plus 4x? Remember, negative 4x plus 4x, those just cancel each other out, right? Those are opposites. So we get 4 plus 2x equals then 16. Okay, at this stage, guys, you can do several different things here. You can do like 3 different things. Okay, but only one of them really makes sense. We want to separate our variable and our constants, right? Our variable is showing up on the left-hand side. So when you get down to this stage where you've got a constant plus a variable equals to a constant, leave your variable where it's at. Leave the 2x where it's at, okay? There's no sense in moving it. Move the constant that is with it. So how do I get rid of this 4? I'm going to subtract 4. If I subtract 4, it's going to give me 0. And then I come over here and keep everything balanced, right? So 2x is equal to 12. Now divide both sides by 2. X ends up being what? X is 6. Okay? Both these examples so far, and it's just the way that they've worked out. This one here, we got our ends on the left-hand side to kind of disappear right away, right? Just by combining like terms. On the right-hand side here, we got our x's to cancel out. If we look at this one, that's not going to happen here. So let's try this one. This is a weird one. Just because of the way the answer comes out, we get an answer to be 0. You're allowed to get an answer of 0. Okay? X or A or whatever your variables can be, it can take on any value that we want, or that, I guess not that we want, that, but any value off the number line that the algebra aligns itself with. Okay? 0 is one of those that people are, that's really not a number. It is 100% a number. It has different characteristics than like 1, 2, and negative 1, negative 2, and those kinds of things. But it is still a number, so it's a valid answer. Okay? I think some people get that and I did something wrong. Okay? You did not do anything wrong. Just let the math kind of unfold and tell you what you're supposed to be doing. Okay, so when you distribute, what do you get right here when you distribute? Negative 5. What about right here? Negative 38, right? I've been working with people individually, okay, throughout the day. They come up and see me during their study halls or whatever, walkout time, that kind of thing. And when we distribute, there's two errors that are being made. One, we're distributing the negative 5 and the 1, and then we write plus 6a. So we forget that we have to distribute to both parts, okay? The other thing that we're doing is that we distribute to the first one correctly using multiplication, but then we go like negative 5 and add to it 6a. And we write down positive 1a. Make sure you remind yourself that distributive property, when you see it, it means multiplications. You have to multiply to everything inside those parentheses. Okay? Now over here, what is this negative really referring to? A negative 1. So I'm going to distribute that, and I get negative 5. And here I get negative 6a, right? Okay. I think it's important to talk about how many different things we can do here. You can do 4 things next. 4 different things. And to be honest with you, you can do an infinite number of things, but it makes sense to do one of these 4 things. Okay? You can either add 5 to both sides. So I can add that 5 there and add that 5 there. Does that make sense? So that's one thing. I could add 38 to both sides. So that's a second thing, right? And every one of these equations that you get that has a variable and a constant on both sides, you have this opportunity of doing 4 different things. I could add 5 here and then add 5 there. And you might say, well, that's the same thing as the first thing that we did. But a lot of times maybe those numbers aren't the same. So that's the third thing. And the fourth thing is I could add 6a to both sides, right? That kind of makes sense? And that's the issue, I think, as a teacher that I have with trying to teach this stuff and getting everybody kind of on the same page is that it doesn't matter what you do. So you might do something different than the person next to you, which might do something different than the person next to them, which might be do it different in the way that I show you or the way I tell you when you come back and ask me. There are options, and we have to understand that there are options, and that might help us then kind of alleviate some of those issues that we might have if we realize that there are options for you to conduct the algebra different ways. Now, that being said, some of those are better than others, okay? But you can do whatever you want. So what do you guys want to do? Add 5? So if I start here, I'm going to add 5 to this side and add 5 to that side. And the reason I'm doing this right away, because all like terms have already been combined, right? Okay? So add 5 to both sides. So this goes away, and that goes away. And now this is a little bit of a different problem. We haven't seen too many like this together, but we get that. Okay? Now, when I added 5 to both sides, was negative 5 plus 5? Does that give me a number? What's negative 5 plus 5? 0. So most of the time, guys, we don't write like 0 minus 38 or 0 minus 6a or negative 6a plus 0 or anything like that. But maybe in this one, just to prove a point, maybe it does make sense to do that. Well, if I put plus 0 there, this is still a constant. Does that make sense? It's still a number that is always that value. It's always 0. If that's a constant, and this is a variable term, can I get that variable term to that side? So I'm going to add 6a. And I'll add 6a. So I get negative 30a plus 6a gives me negative 24a, right? And now on this side, I added those so they go away. I'm left with just my constant of 0. Now think about this. Usually we like that 0 to be something else. Maybe that 0, we would prefer it to be like 48 or 72 or 96 or something like that. But it's 0. And I treat it just like I treat any other number. If it was like 48 over there, I would divide both sides by 24 here, right? Or negative 24. So I treat it just like any other number. I'm going to divide by negative 24. But the only thing that's unique about this is what is 0 divided by any number that we ever want to? It's 0, right? Okay? Now, here's the thing. Most people are not going to go from this blue line here to that line there by adding that 0 in. Most people, you're going to find out that you're probably one of these people, are going to write negative 30A equals negative 6A, and you're going to maybe get stuck there, not be sure what to do, but you're usually going to see somebody write plus 6A, plus 6A. I'm left with negative 24 here, right? Okay, now as I work through these equations and I solve an equation, when you start with an equation, it's got an equal sign in it, right? There is nothing that you can ever do that allows that equal sign to just vanish. Okay, so I see a lot of people say, oh, so I added 6A to the right-hand side, it went away. I added 6A to the left-hand side, I get negative 24A, but the right-hand side went away. So I just write negative 24A, and I'm not sure what to do next. It's an equation, so that equal sign cannot go away, so it's still got to be there. And it's going to answer that question. Okay, well, what would be left over here? You say nothing, but nothing can be symbolized by a number, right? That kind of makes sense, the process for that? I think it's a weird case, just notation-wise, that people come across and they struggle with. But you can, once everything goes away on one side, you are left with 0 as a value, as an amount. Okay? I know a lot of you have asked questions about things like this. Okay? And you will see, I'm not going to give you one more that's got, well, we got 5, 6 terms up there. I'm going to give you something this elaborate, but I will give you one that has fractions in it, or a couple that have fractions in it. Okay? And the idea, guys, is that we want to look at our denominators, which are that number. Would you guys agree there's a 1 right there? That number of 12. There should be a 1 right there underneath that 2. That 2 and that 4. Okay? Now the ones that are not there that I put the highlighter over top of, we don't really need to worry about those denominators as we do this problem. The denominators we have to worry about are the ones that are non-ones. Okay? Values that are different than 1. So, we look at the 3, the 12, the 2, and the 4. And our task is to think about what would be a number that I can get all of those to grow to. Okay? Ricky? 12. Okay? So here's the idea. And this might not, it's the LCD class. Did I show you guys Excel the other day on how to do this with Excel? I don't know, there's one class that I did this with, and the other class I didn't do it with. So I can't remember. Must have done it with 5th period. But what we've got going on here, well, I'm just going to put in our denominators of 3, 12, 2, and 4 here. Now, to get this to do what I want it to do, I've got to do this. And I'll zoom in on it so you guys can see it a little bit better. All right, so these here were our denominators, right? Those are our denominators. If I take those denominators and multiply them all by 2, I get that row of numbers, right? Take those denominators and multiply them by 3, I get that row of numbers, right? What I'm looking for, guys, is a number in this row, maybe that one. Let me see if I can highlight this. I'll look for that number, because it's a 12, and see if I can find basically that number in all these other rows. Does that make sense? Okay. So in this row, I get my 12. In this row, do I get 12? And in this row, do I get 12? Okay. Now, there are other numbers in these rows that I can see. Look down that first row. I guess they're columns. Look at that first column. I get a 24, right? So I can make this number here grow to a 24. Can I make this number grow to a 24? Can I make this number grow to 24? It'd be right there, right? Can I make this number grow to 24? So we see that we can make these numbers through multiplication all grow at some point to the same amount, right? I can go 12, I can go 24. You'll find out that you can make them all go to 48, okay? We can also, we get 36 as well, okay? But the smallest number that we can make them all grow to is 12, right? And the smallest means least. We call it the least common denominator, okay? We've talked about this, and we did a little bit of a discussion the other day about this, but that's how I'm going to decide what I need to multiply all of these things by. I'm going to multiply by 12, okay? So as I go through this, I think it makes sense maybe to, again, color code things. So I'm going to look at this first number here, and I'll multiply it by 12. Well, if I do that, multiply that by 12, I'm going to get 12 over 1, right? That's what I'm multiplying by, 12 over 1 times 2 over 3. What's 12 times 2? 24. What's 1 times 3? 3. So when I do that multiplication, guys, I really get 24 over 3. Well, what's 24 over 3 reduced to? 8, right? Does it make sense then that multiplying by 12 turn that fraction into a whole number? Okay. So now let's go to this one. Let's multiply that by 12. And this one's an easy one, right? Multiply that by 12, I get 12. Here's another one. That's pretty easy. Now, I'm not going to, because I don't know off the top of my head 79 times 12 is. But if I were to do that multiplication, I'll come inside. 12 over 1 times 79 over 12. Can I rewrite that as 12 times 79 over 12 times 1? What's that give me right there? That's 1, right? So 12 over 12 is 1, and I got 1 times 79. Well, let's just use 79. So these things, what a lot of people will do is say, well, let's just cancel. It'll only be 79. Then I'll multiply this one by 12. What's 2 times 12? 24. Okay? And then I get this one. I'll multiply it by 12. So then I get negative 3 over 2 times 12 over 1. 36 over 2. What's 36 over 2? 18, right? So minus 18. I'll do this one. It'll give me minus 33. Okay? But that then is a much easier equation to solve if I can recognize I got to multiply everything by 12. Have a great rest of the day.